There are a lot of transformers available in Workbench, well over 400. This gives FME a lot of flexibility, but it can also make it a little tricky to find the transformers that you want. In today's session, we will review some of the more commonly used transformers and how to find the transformer that you need. There are a couple of ways that you can go about finding the transformer for your particular task. Now, I will mention right off the start that the only way that you can become truly proficient with FME is to be familiar with all the kinds of transformers that we have. And the only way to do that is to, at the very least, read through all of the transformer names. It'll take some time to read through all the transformer names, but I do recommend that at some point in time you do that. So a lot of what I'm about to show you is where you can go find all those transformers so that you can review them. So there are a couple of ways that you can go about finding transformers for your particular task, or at least the list of transformers that apply to you. One of the easiest places to look is the transformer gallery. So in Workbench itself, we have a number of windows, and one of them is the transformer gallery. Mine is hidden right now, so if I go back up to view, we have the transformer gallery. Usually it's on the side here. Quite often it's tabbed with something else. Within the transformer gallery, you can find a list of all of the transformers alphabetically. You can also find them grouped by categories. Now, when I first started working at SAFE myself, I just went through each and every one of these one by one. And as you go through these, if you have the help window also turned on, I'm going to turn on the help there. As I click on it, it'll have additional information about the transformer. Now, the reason why I said that you should, at the very least, read through the names of the transformers is that the name is fairly descriptive. And any transformers that apply to what you're trying to accomplish should jump out at you. Or at the very least, things which don't apply to what you're doing should be easy to identify. If I never deal with ellipses, I don't have to worry about the 2D ellipse replacer. If it might apply to me, maybe I'd work with 3D arcs. I can further read the description of that transformer. Now, if you do fairly specific things, going through the categories might be more helpful, because here I can identify categories which apply to me, or at the very least disregard categories that don't apply to me. If I never work with point clouds, there's 28 transformers I can skip over. If I never work with rasters, there's an additional 70. So this way I can fine-tune which transformers I will actually review. So there's quite a few categories, but there are a few categories that you should review regardless. You should go through all the transformers in the attributes category. This has transformers such as the attribute manager and other attribute handling transformers. You should also go through all the transformers in calculated values. This has transformers like the area calculator. You should also review all the transformers in filters and joins. This has transformers like the tester. Geometries is also an important category. Here you can find transformers like the area builder. We haven't actually seen this in the course. This will take lines and create polygons from it. Very important if you're dealing with cadastral data that starts off in a CAD file. Spatial analysis. This has a lot of the overlaying transformers. And strings. If you have attribute values, which you're trying to work on, the strings transformers will often do that. We can concatenate, we can split, things like that. Now the transformer help, if you have the help window open, anything which you click on the canvas, if I hide my visual preview there, anything I click on, it will bring up that particular help entry for either a transformer, but it'll also do it for feature types and anything else that I select on the canvas or in the transformer gallery window itself. You also have the option of pressing the F1 key to open up the help dialog. There is a search option in the transformer gallery. The search in the transformer gallery can be used to find a transformer that you want, but you should try to think of just 1 or 2 words that describe what you're trying to do. The results include the transformer name and description. This is certainly not a Google search. You wouldn't want to put in, how do I, that's not going to work. It's more like, okay, I need to do something with statistics. What transformers will deal with statistics? The search results show up here. And as I mentioned, they are a search of the transformer name and the description. The quick add just goes through the transformer names. I'll mention this again later on, but if you hit the tab key, it then also searches through descriptions. So you can expand the search in the quick add. Ultimately, I used the transformer gallery a lot when I first started using FME, but once I became comfortable with the transformers, I moved pretty much exclusively to the quick add option. So the quick add search, again, it'll list the transformers just like it does here, but by default, only the transformer name. If I hit the tab key, it will then also search through the descriptions. Sometimes you'll notice that the transformer that shows up in the quick add, or sometimes the search here has a little arrow icon to it, sort of going up. This means that it's actually linking to an alias. We occasionally rename transformers. For example, just recently, we renamed the line joiner. The line joiner is now an alias for the line combiner. I still use grep for the grepper, which is in fact the string searcher. Once you become really comfortable with the transformers that you use on a regular basis, you don't have to type in the full name of the transformer in order to bring it up in the quick add. You can just use the capital letters within the transformer. For example, the point on area overlayer, POAO, that'll bring it up. That can also become really handy if you're dealing with the various raster transformers. So I could do the raster band coercer or combiner. So you can quickly find a particular transformer without having to type in, say, raster, which doesn't actually narrow down the list much at all. There's still a lot of transformers there. You'll notice that some of the transformers, especially in the search results here, have a little download arrow. These are actually custom transformers available from the FME hub. They aren't actually locally installed on your computer just yet, but once you select the transformer, it will be downloaded and installed. Custom transformers are usually for, I guess, fringe cases, very specific actions. For example, if I type in label, I have my labeler and my label point replacer, but then there's also some of the FME hub transformers, adaptive labeler, area labeler, centered label adder. These do labels in a very specific way, which might not apply to what you're doing. It's generally best to review the installed transformers first, and then if they're not quite doing what you want, you may want to take a quick look at what's available on the FME hub. The most valuable transformers. We do have a list here in the manual of the top 30 transformers. The attribute manager keeps climbing up the list. So the most commonly used transformer in FME is the tester. If you're doing any sort of filtering, the tester is a good place to start. If you're doing anything with attributes, the attribute manager is probably the best place to start. And then there's a few cases where the attribute creator is simply nicer to work with. The attribute manager always lists all the attributes that are on your feature. If you have a lot of attributes, that can become cumbersome. The attribute creator simply allows you to create attributes without showing you the entire list of what you already have. I do recommend at the end of the course that you familiarize yourself with these top 30 transformers. There is a place that can make this easy. I can never remember how to get to it directly from our website, but I know it's safe.com/transformers, if I could type it in correctly. This is the transformer gallery on our own website. I'll quickly chat this out to everybody. So you notice that this lists the transformers in the same order that we saw in the manual. So you don't have to go back and review it from the manual. In fact, I would recommend that you come back to this page to review some of the transformers, because on this page you can sort by most used. If you're going to be spending some time learning the transformers, you might as well learn them in the order in which they're most used, because that'll probably apply to you as well. You can also filter by categories here. If I do a lot of work with rasters, maybe knowing which transformers are most used with rasters could be helpful. Or if you're just going through it category by category, then you can skip over categories that you're not interested in, such as point clouds or rasters. Now, with some of the transformers, there is a fair bit of overlap in capability. I just want to talk about some of these transformers that have very similar capability before we move on to the next section. When it comes to filtering, I do recommend starting with either the tester or a very closely associated transformer, the test filter. In all honesty, I kind of prefer the test filter. The test filter takes slightly more time to configure, but it is in fact a transformer that simply contains multiple testers. Each output port is a tester transformer. To demonstrate, say in this workspace here, this is from day 2, we have our tester, not dog park. The tester is one transformer we can use to test attributes. Another one's the attribute filter. The attribute filter works in much the same way. I can choose an attribute to test, and then I enter in the values. If you're dealing with very specific values, the attribute filter is a quick and easy way to do that. The test filter looks like this. I'll connect that. When I open up the test filter, it looks like this. Each one of these if statements is in fact a tester, so there is additional clicking, really just one extra click. And now I'm basically into a tester. Here I can test for dog park equals n, and then I can give it an output port, not dog park. Else, everything else goes out through the unfiltered here. I can call this dog park. Test filter, park type. Now, at a glance, this workspace or this transformer is easier to understand than this one, because I can name my ports, and naming the ports I find is really helpful. That's why I'm a big fan of the test filter. Some other transformers I want to talk about in this top 10 or 12 that are closely related are the attribute managing transformers. The attribute manager is the go-to transformer if you have to deal with attributes. But as I mentioned earlier, because it lists all the attributes on your features, and if you have a lot of features, it can become unwieldy. If you simply want to create another attribute, the attribute creator can also do that. The attribute manager can, of course, create attributes. The attribute creator pretty much just does that. So this can be a cleaner interface if you have a lot of attributes. The attribute manager can also remove attributes, but if you have a lot of attributes and you only want to remove some of them, perhaps the attribute keeper might be a better transformer to use. The attribute keeper and the attribute remover both do the same thing. I can just, with the attribute keeper, select which attributes I want to keep. The attribute remover, I select which attributes I want to remove. You can rename attributes in the attribute manager as well. But again, if you have a huge number of attributes, maybe it's tough to go through and find them, the attribute renamer is another alternative. So ultimately, the attribute creator, attribute manager, attribute keeper, attribute remover, attribute renamer, all very closely related. So we'll talk more about some of the types of transformers. Coming up, we'll talk about some workflows, managing attributes, filtering, and data joins. But first, we'll go through exercise 1. So this exercise is really just practicing searching for and selecting transformers. So what are the most used web transformers? Well, the most used web transformers we can find here in this transformer gallery. If you want to try racing ahead of me here, you can try to answer that before I do. In the transformer gallery, we can go to Web, sort by most used, and there's our most used transformers. So I think that was the HTTP caller, JSON flattener. I think the generalizer was in there. Parameter fetcher. And probably the JSON fragmenter. Let's see if I remember that right. There we go. Now the generalizer seems a little bit out of place there, but you have to remember that if you're doing stuff on the web, you'll probably want to reduce the amount of data you're pushing across the web or across an internet connection. And the generalizer can reduce the number of vertices in your geometry, simplify your geometry. Now remember, with the quick add, you can do partial name searches. So if I did a line co, what transformer would that bring up in the quick add? I actually had to go look this up because none of those transformers look familiar to me. I didn't know that we had renamed the line joiner to the line combiner. The next one to try in your quick add is REAC. I actually use this one a lot myself. and I believe we actually used it in the exercise in day 2. And that's the area calculator. RBIC, this is what I was trying to demonstrate with the camel case, but I forgot the I. So again, anytime you're dealing, or once you're familiar with the raster transformers, they all have very long names. Typing in raster doesn't really help you. Typing in band won't really help you, because again, there's a lot with the word band in it, but knowing the camel case can make life a little bit easier if you're looking for something like the raster band interpretation courser. If you type in drape, trying to think of what this would even do. Dissolve raster area polygon evaluator. That sounds terrifying, so that's definitely not it. And that's just ridiculous. Attribute exporter? I've never used an attribute exploder. Attribute exporter. I think it's the attribute exploder. Let's just see. Yep. I don't think I've even heard of that transformer before. Attribute exploder. Looks like I need to read through the list of transformers again. Okay, based on some scenarios, which transformers are good ones to go with? So we have some lines of text in a file, and we want to read that text in and add it as an attribute. I've quite often done this if I have, say, a configuration file that I want to read in. I'm not necessarily reading it in as a text file. I want to read it in during the translation. Now, a feature reader could technically do that, but the attribute file reader allows you to read in text as a specific attribute value. We need to transpose some X and Z coordinates. There is a coordinate swapper that can do that. We have a point cloud data set. I want to reduce its size by resampling to remove excess points. So the attribute file reader, that would just read in the file contents as an attribute. Coordinate swapper, we just saw that, swap X, Y, and Z. Point cloud thinner, that sounds exactly what we want to do. We want to thin the data. String length calculator calculates the length of a text string. Neighbor pair finder will find the two closest features to a anchor feature. Now we have a text string. We want to find out how many characters in the text string. Again, attribute file reader reads it in as an attribute. Coordinate swapper swaps X, Y, and Z. Point cloud thinner thins the point cloud. String length calculator. That's exactly what we want. And finally, we have a set of addresses. And for each address, we want to find the two closest libraries. That's the one there we haven't selected so far, the neighbor pair finder. We have a neighbor finder, which finds the single closest feature. And then we have a neighbor pair finder, which finds the two closest features. Now, I believe that the neighbor finder will also find the closest features. It finds the features within an area of interest or within a search distance and stores those in a list, which is a numbered array of attributes. You can then work on that list to find the nearest features. But the nearest pair finder is useful if you want to find two features closest to your base feature. The reason why we have something like the neighbor pair finder, it's mostly for working with AutoCAD files. We found that if you had, say, a valve There was usually two pieces of information close to it, and you'd want to attach those to that feature. Readers and writers are not the only way to access data in FME. I believe yesterday you were introduced to the feature reader and the feature writer, but there are also a variety of transformers that can be used to read and write your data. Here's some of the key workflow transformers. For reading and writing from a specific format, the feature reader and feature writer are very handy. If you're working with web services, the Dropbox connector, Google Drive connector, Salesforce connector, etc., we have a number of connector transformers that can be used to interact with those web services. They can read, they can write, they can also do other actions. If we simply want to deal with attributes, we want to quickly read in a file and store its contents as an attribute, or quickly write out a file using the value of an attribute as its contents, the attribute file reader or attribute file writer can be quite handy. I often use the attribute file writer in combination with a system caller. That way I can quickly write out a text file and then use the system caller to execute it. This can be quite handy if I want to work with, say, JavaScript, say Node.js. I can write out a JavaScript file and then execute it with the system caller. Or batch files are another option. I often use this as well if I want to interact with GitHub. You notice that Git is not one of our connector transformers just yet. So I'll install Git on my machine, write out the Git command into an attribute using the attribute manager or attribute creator, combine that with an attribute file writer to write it out into a batch file, and then execute the batch file, which will run that Git command. We can also send and receive packets, JMS, SQS, TCP/IP, etc. Going into a bit more detail, the feature reader allows you to read in data during the translation, as opposed to just at the very beginning. It's also really handy if you want to use a spatial filter when reading in data. So you have an area of interest that'll come in through the initiator. I can grab just the data from that area of interest using the spatial filter. This also means that I can start up a translation, grab some file names, or put together some file names to read in additional files. I have an orthophoto catalog here. This just has the name and the image file location. I can then use the feature reader to actually read in that orthophoto. There's a number of spatial filtering tests. I can have things that are within, that are outside, etc. So then if I need to find, say, postal addresses, which are within a park, I can read in the parks first and then just query for that, for those particular postal addresses. If I'm reading from a database with a spatial index, this can greatly improve the performance of my translation. The feature writer is a writer within a transformer. I find that this is really handy if I need to write something out and then perform some additional actions, such as emailing the results of that translation. I can create the output files and then email them. The readers can directly read from a variety of web sources. So when you are adding in a reader, we can select data from web. You can specify a URL directly. So if you have something being kept at a URL, you can read that in directly. But keep in mind that if you're reading in something like an Esri shapefile, Esri shapefiles consist of multiple files. The URL won't work for that. It has to be zipped up. When you specify a URL, everything has to be within the file that you specify at that URL. But remember, FME can read in zip files, so that'll work. We can also read directly from these various web services. but the writer cannot write to those web services. If I want to write out or perform other actions with those web services, you'll want to use the integration transformers, these various connectors. So we have integration transformers available for Autodesk A360, Dropbox, Google Drive, Amazon AWS S3, Box, OneDrive, and FME Server. For example, here's an example, reading in some parks, and then grabbing some additional files which are stored in Dropbox. I could then write those out and then use another Dropbox connector to write it back to Dropbox. For managing attributes, there are a number of transformers which you can use. The Attribute Manager can do most of the options here. So let's look at the various tasks here. You'll notice that Attribute Manager is available for almost every single one of these tasks. So creating attributes, the Attribute Manager should be your go-to. If there's too many attributes already on the feature and it's tricky to use the Attribute Manager, try the Attribute Creator. For setting a specific attribute to a specific value, again, the Attribute Manager can do that. Again, if you have too many attributes, try the Attribute Creator. Removing attributes, Attribute Manager can do that. If there's just one or two attributes I want to keep, use the Attribute Keeper. If there's just one or two I want to remove, I can use the Attribute Remover. If I want to remove all sorts of attributes that I could apply a test to, a filter to, basically a regular expression. I want to remove everything that starts with the word AutoCAD. I can use the bulk attribute remover. Renaming attributes, again, Attribute Manager. If I have a lot of them, the Attribute Renamer. If there's some sort of pattern to what I'm renaming, again, the bulk attribute renamer can do that. Copying attributes, if there's just one or two, the Attribute Copier can do that. The Attribute Creator can also copy attributes. And of course, the Attribute Manager. Sorting attributes, that's the Attribute Manager. Changing the case of all of the attributes. Quite often, if you're writing out to a database or reading in from a database, databases often have a limitation on uppercase or lowercase attribute names. If I want to change all of them to uppercase, all of them to lowercase, or change them all to title case, the bulk attribute renamer is very handy for that. Or if I wanted to add prefixes or suffixes, I could use the bulk attribute renamer again. I'll demonstrate lists in an upcoming exercise. Lists are a way of allowing FME to store multiple attributes of the same name on a single feature by putting them into a numbered list. This is basically like an array. I have a number of attribute values for my attribute, and then I put them into a numbered list. So I have my list, element 0, 1, 2, etc. Now you can see a better example of that. I have a tree list. I have my element 1, my first element, element 0, element 1, element 2. These would be 3 different trees. I could have more than just the species attribute. I could have all sorts of additional attributes. I could have species, age, tree cover, things like that. And then I can store those attributes. And then there's a number of transformers that can deal with lists. If you want to find them in the quick add, just type in list. Okay, so this just has a bit of a deeper dive into the various transformers, creating attributes. You've already done that in the Attribute Manager. Constructing attributes. As I mentioned the other day, in session 2, we were going to create a text label using a string concatenator transformer. Anytime you end up having to use a string concatenator transformer, just keep in mind that you could create the text value within the transformer itself. using the text editor. If you're doing a mathematical expression, you could also use the arithmetic editor. In the voting analysis workspace, we used an expression evaluator to calculate a, what was it? The elevation factor. We were multiplying that. I can't remember the specific term for that at the moment, but we wanted to exaggerate. That's what it was. We wanted to exaggerate the z-axis. We used an expression evaluator. We could have actually done that directly within the 3D Forcer using the arithmetic editor. So the text editor is in fact the string concatenator, and there's a number of string functions you can also perform. So we can do things like trim, work on cases, things like that. And there's the arithmetic editor, and again, there's also a number of functions you can do mathematically. There's also some FME feature functions you can do as well. Under the FME feature functions, some which I often use are area or length. It means that you can calculate the area or length of that particular feature at that moment, as opposed to using an area calculator or string calculator to create an attribute with that value first. Now, while it's possible to replace a number of transformers by using these functions within an attribute manager or attribute creator, try not to do that excessively. If you are using these FME feature functions a lot within attribute managers, you are, to an extent, hiding what you are doing from the next person that inherits your workspace. When they're looking at the workspace and they know that you created or calculated an area somewhere, they're going to be looking for an area calculator transformer. If you have that buried somewhere in another transformer, it can become difficult for them to find it. So with your parameters, you can also use the value of attributes as a parameter value. Construct them using the arithmetic editor. Renaming and copying attributes. Again, shows you a quick list of the capabilities here. The attribute manager can do all of it. But sometimes, you notice here with my attribute copier, instead of having my view cluttered by all of the attributes that are currently on the feature, I can just choose what I want to copy. So if you're dealing with features that have large numbers of attributes, sometimes the attribute copier, attribute renamer, or attribute creator can be easier to deal with. Bulk attribute renaming. We'll see this again later on. This allows you to perform a variety of actions on a feature, acting on the attributes, such as adding a string prefix, changing cases, things like that. So if I have to deal with a large number of attributes, say I have all these all as uppercase, I want to make them lowercase, the bulk attribute renamer can be handy for that. It could also be handy for removing things like this PSTL. Perhaps I don't need that. I could replace that with blank to get rid of that prefix. Or I can add a prefix if necessary. Removing attributes. Again, we have the attribute keeper, allows you to keep the attributes. Attribute manager, you just go through and select the ones you want to get rid of. If I have a large number of attributes I need to work on, this is unwieldy. The attribute keeper, remover, or bulk attribute remover would be an easier way to do it. So with the bulk attribute remover, I can use a regular expression to identify what I want to remove and remove all those attributes. Okay, so this brings us to exercise 2. There are 3 exercises in today's session. They each build upon each other. The source data set is an addresses file, contains all the postal addresses. Ultimately, we want to create a Microsoft Excel output file. Let's just pretend this is for a mailing list. The mailing list system expects an Excel spreadsheet of a particular layout. So we need to take our addresses, find the addresses that we're interested in, and write it out to an Excel spreadsheet. The first thing we need to do is manage the attributes, manage the schema. So let's take a look at our data first. I am going to maximize my screen here. I need a new workspace. So open up a blank workspace. Just click on New. That'll give you your blank workspace. I want to make use of my visual preview window. So I'm going to bring up my visual preview window. There's my visual preview. And now I'm going to find my addresses GDB file. So let's open up a file explorer. And the data should be in /FME data 2019 /data /addresses. I'll chat that out to everyone because I'm blocking the view of my manual at the moment. So that's in C, FME data 2019, data addresses. Here's my addresses GDB file. File geodatabase is technically a folder. I can drag this whole thing onto my visual preview. That seems to have made my computer unhappy at the moment. There we go. Takes it a moment. So it identifies this as an Esri geodatabase, file geodb open API. Whenever you drag and drop formats, whenever you have FME guess the format of a data set, make sure you double check. There's a lot of different file formats out there which have the same extension. FME just grabs the first one from the list. So we're going to use the file geodb open API reader. And we can just click OK. If we went into parameters here, we could actually choose the table list. With file-based databases, if you don't choose a specific table, it brings in all the tables. This is different from reading in from, I guess, a live database, something like SQL Server, Oracle Spatial, PostGIS, Postgres, things like that. With those types of databases, if you don't choose a table, it doesn't read in anything. But I can leave the table list empty, and it'll read in all the tables, all the feature classes. Okay, I'm just going to maximize this for a second while we take a look at what we have. So if I click on geometry here, I can see the geometry of what we have. We have also here with the display control. So we have two feature classes, postal addresses and postcode boundaries. We're not interested in the postcode boundaries. We're not going to be doing anything by postcode. So postal addresses is what we're interested in. We can see that it has 13,597 features. The coordinate system is UTM 83-10. If I select a feature, my feature information window will also tell me that. Useful to know that this is coordinate system aware and what coordinate system it is in. Okay, I no longer need my display control, so I'll turn that off. I don't need my information window, so I'll turn that off. The geometry no longer interests me. What I can see here is that I have these attributes: an object ID, global ID, owner name, postal address, postal city, postal province, int state. Don't even know what that would be. Int postal code. Country, represent, status, last update, last editor, and postal code. I'm only interested in a few of these attributes. The attributes that I am interested in are currently contained in a template file in an Excel spreadsheet. So once I get that in, I'll be able to know what I actually need to copy across. Okay, so now I actually want to read in this data set. Now, I often use feature readers. I'm a big fan of that particular transformer. Personally, I use feature readers more than just using readers. When you go to add a feature reader, there's two ways we can do this. We can either begin with the creator. In the beginning, there was a creator. There we go. And then add a feature reader to it. So type in creator, type in reader, and then you can drop in your feature reader. The nice thing about doing it in that order is that I can then click on it and configure my feature reader. Something I wanted to bring up of the behavior of Workbench is when I add something like a creator, it only has an output port. So when it does its automatic adding, it knows to add it on this side. So let me just show you. If I type in reader and bring in my feature reader, if I type in creator, it'll add it on the correct side. So you can add either one of these first. It's still quick and easy just to type it in. So add your creator, add your feature reader. I'll give everyone a moment to catch up. Once you've added your feature reader, click enter again, and it will bring up the parameters for your feature reader. With a transformer name, I find with feature readers, it's very important to indicate what it is you're reading with your feature reader. We are going to be bringing in our addresses. So add that to the transformer name, just makes life easier. The format, we can see down here, Esri Geodatabase, File GeoDB, Open API. I'm just going to type in Open API. There's not many formats that have an Open API, so that brings me straight to the Esri Geodatabase, File GeoDB, Open API. Hit enter. Now, you may notice here that I didn't have to enter the name of the data set. FME tries to be helpful in suggesting the most recently used data set for a particular format. So it automatically populated my data set. Be careful with that. Make sure that is in fact the data set that you're interested in. If yours did not auto-populate that, please go and select the FME data 2019 data addresses addresses.gdb. Now, if you have that already there, I just wanted to demonstrate something. You don't have to follow along this part here. If I open up the folder browser, you'll notice that the selection dialog for File Geodatabase looks a little bit different than all the other file or folder selection dialogs. That's because File Geodatabase is technically a folder. It's a weird thing. You're basically treating a folder like a file, so it has a different interface. What I wanted to point out here is this little look-in thing here. If you work with File Geodatabases on a regular basis, I can either drag across here as a shortcut the folder that has my geodatabases, so I can quickly navigate to that, or I can drag the geodatabase itself over. and I can use that as a shortcut. So if there's a particular file geodatabase that you use all the time, that's a quick and easy way of dealing with that. A little difference in behavior here. When I click on the parameters, when I clicked on the parameters when I was inspecting the data, that uses the parameters like a normal reader. And in that, I saw my table list. When I go to the parameters here, I do not see a table list. The table lists for the feature reader are not selected in the parameters. Instead, it is this feature types to read. This shows up for your datasets regardless of the dataset. And then I can choose my datasets to read, or my feature types to read. So let's click on that and choose our postal address. That's our feature types to read. I can't specify a where clause. The where clause only is available if that format supports it. If I was reading in a file geodatabase using the, what's it called, ArcObjects reader, then I would have a where clause available to me. The spatial filter, we'll come back to that. We will be using that. Let's see some of our other options here. Schema and data, we don't need that. Caching, we don't need to do that. Output ports, we could do one per feature type, or you can have a single one, or you can specify which ones you want. Generally speaking, you'll want the one per feature type. Attribute and geometry handling. Now, this can be important. I often mess up this one. If you're using an area of interest feature, if you're using some other feature from some other data set to retrieve these features using your spatial filter, you'll want to make sure that you keep those features. Or if you have some other action happening before the feature reader, a parameter fetcher perhaps, retrieving some attributes and then using those attributes to get your data. For example, you have an attribute that has your feature type names or something like that. You may want to make sure that you merge the initiator and result. I'm going to leave this as only use result for now, so we can deal with that later on. So here on my creator, I have my creation instance. On my postal address, I do not have that creation instance. In this situation, that's for the best. But if I had other attributes that I was using to read this in, I may want to merge those together. Okay. So now we've got that. So far, we have these attributes. Now, generally speaking, I try to run my translations often just so that I have everything all cached up, but also if anything's going wrong, I know about it right away. So now I have my postal addresses, and I can see that I have 13,000 of them. Handy. We should probably save our workspace at this point. Let's go up to save. And we'll save this as exercise. What day is it today? Day 4. This is technically exercise 2, exercise 4.2. So save your workspace. For step number 3, we're going to add an Excel writer. We could use a feature writer transformer, but instead we'll just add a writer in the usual way, mostly because I wanted to show off the import from dataset option for the feature types. So click on a blank spot on the canvas. We can use the quick add to add the writer. You can go up to writers and add the writer there. Instead, we're just going to type Excel. Here we can see in the quick add, we have our readers. We also have our writer. So I'll hit enter. brings up the Add Writer dialog for our Excel writer. Our data set, the file doesn't exist just yet, but we can still navigate to the output folder. So that is /FME data 2019 /output /training. And then we can enter the name of the file. It will be address file.xlsx. With some formats, keep in mind that the extension that you specify is very important. It'll actually affect how the file is being written. So here we have the XLSX, XLSM, XLS. Those actually end up being different types of files. This can be very important for those of you that are writing out to AutoCAD DWG files. You can write out to a DWG file, which is a binary file, or to a DXF file, which is an ASCII file. So we'll save that, check the parameters, overwrite existing file. We can come back to this later on, but this is one of those parameters which it's a good idea to be checking for when adding a writer and then thinking it through a little bit. With Microsoft Excel, it can be treated, I guess, kind of like a database, where every time we run the translation, we append onto the existing tables, or in this case, sheets. We don't want to append every time we run the translation, so we want to overwrite the existing file. Now this does bring up an interesting thing here. We can use a template file. We actually have a template file, which is an Excel spreadsheet. The template files here can only be other Excel spreadsheets, so we could technically use that. But I wanted to show off the importing feature type definitions because sometimes the schema that you want to use exists in a file which is not of the actual format you're writing out to. Perhaps you have an XML document that contains the desired output schema. In that situation, the the XML file would not work for us as a template file. So we're going to leave the template file blank. It's an Excel spreadsheet, so it doesn't have a coordinate system, so we'll leave that empty as well. For the sheet definition, we could make it an automatic one where it sets all the attributes based on what's coming in. We could manually specify it. We can import from a data set. So that's what we're going to do. We're going to import from an existing data set. So get all that configured. I'll give everyone just a moment. And now we hit OK. So now it's going to prompt us for the data set that contains the desired output feature types. This file here has the desired output sheet name and the desired attributes already defined. So it is an Excel format. Well, let's actually go find that actual file. It is in /FME data 2019 /resources /desktop basic. And in the desktop basic file, we have the address schema Excel spreadsheet. So select the address schema Excel spreadsheet, hit OK, and then hit OK again. And that brings in our postal address sheet, and the desired attributes are already defined. So now we need to make these attributes match up to these attributes. We can see with the color coding here that as of this moment, none of them match up. So we need to do a fair bit of attribute management. Whenever you have to manage attributes, think of the attribute manager. So let's drop in an attribute manager transformer. And let's take a look at some attributes. Now we've got 13,000 features coming in. You can imagine if you're doing this at a country or province or state level, we'd have way more features than that. Every feature that you have, if it has attributes which are not being used, that is consuming memory, increasing the memory footprint or memory overhead of that particular feature. You can improve performance of your translations by removing unnecessary attributes. So we do not need object ID. If I hold down the Shift key, I can get the global ID. We don't need the owner names. So I can remove those ones. Let's see what else we don't need. We do need the postal address. We need the postal city, postal province. In-state we don't need. The int postal code we don't need, so we'll remove those ones. Represent, status, last update, last editor, we don't need, but we do want postal code. So we'll remove all of those. I'm going to hit OK here just to save the work that I've done in case I misclick on something. And I can also see that I have a much smaller list of attributes to deal with. So now let's deal with some renaming. Postal address. This actually will eventually be broken up to be our street and our number. The postal address, the first number on it will be our number, the rest of it will become our street. We can't really deal with that right here at the moment, so we'll deal with postal address later on. Postal city, that'll become our city. Postal province will become province, so I can select that. Country will become country. If I had a lot of attributes where I was just changing the case, the bulk attribute renamer might be the better way of doing that. But in this situation, there's only the one. Postal code, we're actually converting to camel case. The bulk attribute renamer would not be able to figure that out, so we need to do that ourselves. Postal code. Hit OK. Now we can see we have some green here. City, province, country, postal code, those are all matching up. Now we also have these additional attributes, provider, update date, and event. We're going to use the attribute manager to set our provider and update date. Event we'll deal with later. So step number 7, let's go back to our attribute manager. Down here at the bottom, we have add new attribute. We'll click on that and type in provider. And then you can put your name in. So we're creating an attribute with a constant value. After you've added your provider and set it to a value, we'll go to step number 8. We want to set the update date. Now this could have been done with a time stamper transformer, but we can also do it directly within the attribute manager. So for the update date, click the down arrow and we'll open up the text editor. The text editor would also be this 3-dot button here. Both of those will take you directly to the text editor. In the text editor, we have all the functions down the left-hand side. Later on, when you need help with those functions, keep in mind that under the help here, we have the help for the transformer in general, we have the help for the text editor specifically, and then we also have help entries for the various types of functions. So if you need help with the string functions, what they do, what they mean, or the math functions, or the date time functions, you can find it there under the help. Let's expand our date time functions. There's a number of them. Date time add sounds like the one that you want, but this is actually, I believe, adding time to a existing time. What we actually want right now is the date time right now. So find date time now and double click on it. It creates a date time in ISO syntax, which for us will be sufficient. So we hit OK. Now we have our update date. Hit OK again. You can see we now have our provider and our update date. We're making good progress. Let's run to the attribute manager and inspect what we have. Okay, so we have our city, province, postal code, update date, postal address. We can see examples of the postal address. We have the number, which we'll want to populate number, and then we have the rest of it, which will become our street. We have our provider and we have our update date. Okay, so now we need to squeeze postal address or split postal address into number and street. There are a number of ways that we can do this. So let's take a look at a more or less straightforward way of doing it first, and then we'll take a look at some other ways of handling text strings. So first up, let's give ourselves a bit of space to work with. I'm going to drag my attribute manager over, my postal address over, so I'm going to drag them over here. So I've got a bit of space. When your workspace starts getting large like this, one of the things that you can do to make life a little bit easier, and just so you can see where I am in my workspace, there is an overview window. It looks like this. So the overview window shows the entire workspace. You can grab the little square there and move around. So between my feature reader and my attribute manager, I'm going to drop in an attribute splitter. The attribute splitter is used to split up an attribute based on a delimitation character. Oh, someone said we can highlight more than one transformer and move them at the same time. Yes, you can. I just didn't manage to do that. You have to get completely around it in order for it to happen. And with my view before, I couldn't quite get there. That's why I was moving them one at a time before. Okay, the attribute splitter. In the attribute splitter, we are going to split apart our postal address. Notice you can select, I believe, more than one attribute. For us, we'll stick with postal address. The delimiter, usually it's something like a comma or a pipe or something like that. Using the text editor, you can even choose special characters like tabs and the such. We are going to be splitting it based on spaces. So select the text entry box there and just enter a space. It'll look like you didn't set it, but there's a space in there. This will create a list called list, and we'll hit OK. Now let's see what this gives us. Let's run to the attribute splitter. Inspect what we have. Now the table view here doesn't necessarily show us what we need because lists don't show up in the table view. The only way you can see lists is with the information window. So I'll bring up the information window. Brings it up in an odd spot there, but in any case, let me move this around. There. Okay, so we have our information window here with our feature. We can see our postal address for this particular feature, which I had selected, 989 Butte. You'll probably have a different feature. Oh, there we are. Just took me a while to find the correct feature there. Okay, so now we have a feature and it's splitted apart based on the spaces. In this case, it's 1188 West Pender Street is now the one that I've selected. So list element 0, that'll be the first part. 1188, that's our number. So list element 0 gives us what we want, and then we have the rest of it in the rest of the list. So now that we have our features in a list, we can go back to the attribute manager and start renaming our list, because now we have our list attribute. So let's go back to the attribute manager. So I'm in the attribute manager now. Now I can't rename it directly. What I can do is copy or create a new attribute and copy list element 0 into it. So add a new attribute. The new attribute is going to be number. And then for the value, I can set an attribute value. I could also do this through the text editor, but I'm going to do it through this instead. So attribute value, I can choose the list. I can't copy an entire list into an attribute. I can only copy into it a specific list element. So once I select this, it'll ask me which list element I want copied into number. So I can go list, I want list element 0, the first element in the list. So the default will work, and then you can just hit OK. So I click OK. Now I can see that I have list element 0 being copied into number. I can run into my list element, into my attribute manager here. We can see numbers now being populated. And when I inspect it, I have my number and it's 1188. If I look at my feature information window, I can see that I still have that entire list. It did not rename list 0 into 1188. It just copied it. Now the next step is getting the rest of that list into an attribute. So here's what we can do. If we go into the attribute manager, we can create a new attribute, calling it street. And its value will be the value of the list. So we created a new attribute called street. We go to the text editor, for street. We then have our list here. When I double click on this, it'll ask me for a list element. I want list element 1, space, double click on it again, list element 2, space, double click on it again, list element 3. And this will concatenate it all together. So now I have that, I run this again. I shouldn't have written out the whole thing. It takes time to write out to the Excel spreadsheet. Run 2 should have been faster. I can inspect the data. I still have my postal address. But I can see I have my number. Whoops, I sorted there by accident. I still have my number and I have my street. So this works. Now there's some limitations to this though. First of all, if I have something that has less than 3 there, like this Glen Drive, I've concatenated on another space there. I probably have a space at the end there. Yep, I do. Okay, so Glen Drive has that space. I could probably handle that by putting all of that into a trim option. So now this part here, I don't want you to try to do what I'm about to do. I just want you to observe. So dealing with sort of fringe cases there with my street, there are a number of string functions. Perhaps I think the trim, I've never actually given a shot, but the trim might be able to fix that and get rid of those extra spaces. And I could have checked my string function help to see if it actually would do it. So I have my string functions, I have trim, there's also trim left and trim right. Here's trim, there we are. That'll just match, get rid of those characters. There, so maybe trim left or trim right would probably do what I need. So that could handle those additional spaces. Another thing to worry about is I'm assuming that there will be at most 3 extra words, I guess, at the end, 3 extra values. If I had some really complicated name with a lot of spaces in it, I could end up with more than 3, and then all those additional ones I would lose. So while this works, it needs some additional contemplation of fringe cases. So the next option is to be a bit more dynamic with that list. I have the list. Let's see what list transformers I have. I have a list-based feature merger, list builder, list concatenator. This will concatenate together all the values of a list into a single attribute. This is exactly what I want. So I'll drop in a list concatenator. And then I can concatenate my list with spaces into my street. I think that'll work perfectly. Let's give this a shot and see what happens. So this is actually going to overwrite my existing street with my new concatenated street. And let's see what I get. 1188 West Pender Street. It gave me exactly what I started with. So this isn't quite right. Obviously, we need some fine tuning. One of the options in here is to drop empty or null elements. I'm going to set that to yes. So it'll drop an empty element. Now the reason why we're ending up with the whole thing coming back here is that when I look at my list, I still have my element 0, but we can fix that. The attribute manager, in addition to renaming attributes or copying attributes, can get rid of an attribute. So I have my list 0 there. So attribute output. What I can do is create a new attribute. This is a bit of a trick. I'm just going to manually type it in, _list 0. I am creating an attribute, overriding that part of the attribute. Now I want to set it to a value. The attribute value here in the drop-down, I can set to null. So now I've taken my list element 0 and I've nulled it out. So now when I run this, list element 0 is now nothing. It'll be skipped over when I concatenate. And now I get my street. It's dropped that number from the street. So now with any length there, it'll work just fine. And when I look at my Ontario street here, I do not end up with that trailing space. So the list concatenator works better. It's not the best. Ultimately, for those of you who are going to be working with streets, you shouldn't be using the list concatenator. You shouldn't be worrying about all that stuff going on. Number and street we'll come back to in just a moment. I'm just going to get rid of that entry there. We shouldn't even be using the attribute splitter. For those of you working with street addresses or something similar to it, the transformer you should be using is the string searcher, what used to be called the grepper. The string searcher uses regular expressions. So I'm just going to find a street here. I just need one. Double click on that, copy this. I just need this to experiment with. Again, don't be trying to follow along with this. This is just demonstration. In my string searcher, I can search my, where is it? Postal address. Contains regular expression. I'm going to piece together my regular expression. I have my test string here so I can see if it's working. There's also a quick reference. This is really handy. I want any digits. Notice it highlights that. If I do a /s there, it sort of gets any digit and then the white space. If I do a plus there, now it'll grab all that digit, my white space, and then I need anything that comes after that. That could be numbers, it could be letters. I need anything. So a period with another plus sign, any number of, that'll grab the rest of it. So that'll get the matches. Now I need to put those matches into a list. With my regular expressions, to get it into a list, I put brackets around what I am interested in. I need any digits. I don't care about the space. And I need everything else. So this regular expression will grab this and the rest of it. List element 0, list element 1. Now, in the advanced here, I have my all matches and sub expression. When you're first working with this, what I would generally do is see what my all is, see what my sub is, and then just run the translation to here and then inspect it to see what I get. So again, those lists, they don't show up anywhere in here. Now I still get my first match, but the first match is just giving me the whole thing. I need to select a feature and take a look at it in the feature information window. So I have my first match, I have my all list, and then down here I have my sub list. And there I can see my sub 0 part and sub 1 part. Those are the ones I want. Sub 0 part, sub 1 part. I can then delete that. I don't need those attributes at all. No point in creating attributes you don't need. I just need to remember my sub parts. And then in the attribute manager, I have my sub part. I'm not going to rename those. What I need is my number and my street. Okay, so list is gone. My number is subpart 1, or sorry, subpart 0, and my street is subpart 1. And then that will give me everything I need. So if you're doing anything advanced with text strings or attributes, you need to split them apart. The string searcher is one of the best transformers to use. The trick is you have to know regular expressions. So there's my number and there's my street. And there's no trailing spaces. And it'll deal with any number of entries there. Okay, one final step here. We want to set event. We could set event in the attribute manager. I think that setting it in the attribute manager is the best way to do it. But there are times where if you're going to do it globally, you can set it directly on the output. So let's go into our postal address feature type, go to user attributes, and you can actually set a value directly here. Noise control update. I just noticed that they misspelt noise. And now event is set directly with what's called a constant. And now we can run that right out to our postal address. Inspect it. And we have our number, street, city, etc., all the way over to our event, noise control. Okay, let's save our workspace and continue. Transformers that filter don't transform data content, yet surveys show that they're the most commonly used type of transformer that there is. Filtering is the technique of subdividing data as it flows through a workspace. Some filters, such as the geometry filter or sampler, apply a fixed filter. They separate data by geometry or pass through every nth features. Others, such as the tester, conduct conditional tests. For example, does this feature have an area above a certain threshold? There is a number of transformers that filter. This is one of the categories that you should review no matter what. You can find all the filtering transformers in the filters and joins category. The most commonly used filtering transformer is the tester. We've used that quite a bit. If you find yourself in a situation where you have tester followed by another tester, try the test filter. For multiple clauses within this, so far I think most of the tests have just been one entry. You can also do something and something else. The logic here has a number of options, so you can put together as complex a test as you like. You can have ands as well as ors. So road type equals arterial, and estimated snowfall is over 150, or temperature is less than 0, as well as last treated was more than 24. There's also a number of operators that we can work with. The usual greater than, less than, equal to, not equal to. We also have a number of SQL-based operators. in range, in, like, contains, begins with, ends with, regular expression. You can also look at types of data or whether or not the attribute even exists. Does it have a value? Is it null? Is it an empty string, or is it missing? Notice that those are all different things. Just because something's null, that's different from having it completely missing, or not having a value, or being an empty string. My favorite filtering transformer is not the tester, it's the test filter. This allows you to have multiple testers within a single transformer and also gives you the ability to name the output ports, which I find really helpful for understanding your workspace at a glance. Because now we have really descriptive ports. Some additional filtering transformers, the attribute filter, if you're looking for a specific value. These are road types here. The attribute filter is really handy for that. This is easier to set up than a tester or a test filter, specifically because there's an import option. You can import all the possible attribute values from a data set. So I have a snowfall data set. I can read in that snowfall data set looking for road types and then have it auto-populate all my various road types. They'll all be here, and then I can start dealing with them. There's also these additional options of empty, missing, null, or unfiltered. Anything which is not in the list and is not empty, missing, or null will go out through unfiltered. Limitation of the attribute filter is that it's looking for discrete values. If you're dealing with numbers, you need ranges. You could do that with a test filter again, but sometimes the attribute range filter is just easier to deal with. The attribute range filter also has the benefit of naming your output ports. Notice that this has from and to. If you leave your from empty, that means negative infinity. If you leave your to empty, that is positive infinity. Sometimes it's necessary to filter by geometry. This is especially true if you're dealing with cadastral data, data from CAD files specifically. Quite often they have geometry, multiple types of geometry in a single layer. You'll have lines for your parcels. You'll have a text or a point feature containing additional attributes. You'll need to separate all of that so that you can deal with it. Separate your areas out, separate your lines so you can create areas, and then work with your points with something like a point on area overlayer to combine the attribute on that point onto your areas. So let's continue on with our exercise. We have all of our postal addresses. We have it the way that we want it. I'm just going to put a bookmark around all of this. So this is select all that, Control B, addresses, address points. So those are our address points. We want to do some additional work on this. We want to grab points that are within a certain area. We want to find all of the single family homes within 50 meters of a major highway. So we need all address points that are single family residences within 50 meters of a major or arterial road. So let's bring in our additional data sets. First of all, we need single family residences. If we look at all of our address attributes here, there's nothing on there indicating whether or not this is a single family residence. That information is being stored in a zoning polygon tab file. The zoning data will indicate if an address is zoned for single family residences. We'll just assume that it is a single family residence at that point. We also don't have anything indicating whether or not it's within 50 meters of a road. We'll buffer out our roads AutoCAD file to 50 meters and then use that. So let's add our additional data sets. First of all, we're going to add an AutoCAD reader. So if you just type in on the canvas DWG, we can choose our AutoCAD DWG reader, which is the second one here. There, that's the one we want. Autodesk AutoCAD DWG DXF. So select that reader. That should be the second one listed. There we go. So we have our AutoCAD file, which is FME data 2019 data transportation complete roads.dwg. Let's find that. Backslash FME data 2019 backslash data backslash transportation. And in transportation, we have complete roads. Now, before you drop this reader in, we do have to double check the parameters. There's an important one with this. The parameters, attribute schema. We need to group entities by attribute schema. Now let me explain why. With some AutoCAD files, attributes are stored as extended entity data. If you've never heard of extended entity data, don't worry about it. For those of you that work with AutoCAD files with extended entity data, I've probably just gotten your attention. It's very important that you group entities by attribute schema, otherwise FME will not read in the extended entity data. So I've grouped by extended entity data, the coordinate system, unknown. If you see unknown, you should set the coordinate system. So we should set this to UTM 83-10. I'm not actually going to do that because I want to show a trick later on. So I'm going to leave this as unknown. So we hit OK. It gives us a feature type list. We have arterial, collector, non-city, etc. The only one that we are interested in is arterial. So we can unselect, select all, and then select arterial. And we'll hit OK, and there's my arterial. So we've added our roads. Let's see, I've had a couple of questions come in. Now, why is the preview of the output grayed out? The preview. I think if you have nothing actually selected, that might be grayed out. Or if I haven't run it yet, so I haven't actually run arterial. Oh, right there. Why is that grayed out of the preview? That's a good question. That should not be, although I can inspect it. I think that this is currently grayed out because I haven't actually run. Let's just run that and see if that gets ungrayed. Yep, there we go. Okay, so the preview, that's just for the caches. Can't inspect it until we have an output. This view source data, that would have worked regardless. Next one, how did I group the address points grouping again? Oh, this box here. This is a bookmark. For a bookmark, you just drag a fence around what you want the bookmark around. So I dragged a fence around the whole thing, and then I hit Control B to add a bookmark. Bookmarks are really handy. We'll see more of that in tomorrow's section as well. So I have my arterial. It's just a bunch of roads. I can quickly inspect that. Looks like this. Now, I don't have a background map on that. Let's see. Background color. No, won't worry about that for now. Okay, next up, I need my zones. So I need to add in my Map Info tab reader. So I'm going to bring in my tab. And I want to bring in my zones data set, FME data 2019, data zoning, zones.tab. So I've added my tab reader, or I've actually, yes, my tab reader. I'll select that, backslash FME data 2019, backslash data, backslash zoning. And there's my zones. So add a Map Info tab reader and go find FME data 2019, data zoning, zones.tab. And here's my zones. A couple of attributes there, zone name, zone category. I can quickly inspect this. I have zone names, zone categories. So I have zone categories of things like industrial, commercial, one family. The one family ones are all the RS for residential single family, but there's a variety of RSs. Let's see if I can find an example there. There, RS1, there's RS2, RS3, etc. So I want everything that begins with RS. So here's my workspace. I have my zones. I can add in a tester. I mentioned earlier I prefer the test filter just because I can name stuff. So I'm going to actually drop in a test filter instead. You can drop in a tester if you prefer. So there's my test filter. So enter zone. And I will test for zone name. Nope, that's zone category. Zone name begins with RS. My output for port will be single family. You can just use a tester and not bother with the output port. Other. So I have my single family and my other. Now, all of the address points I want are within those single family zones. So I can actually use that instead of my creator. So I'll let everyone finish getting their single family zones. You might even want to run to that and inspect what you have. So I have my family there. So I have 19 features. So I have 19 single family zones. And let's connect that up to our feature reader. So that's going to be the input for our feature reader. Once you've connected that to your feature reader, we don't need that creator anymore. These are going to be the initiators for our feature reader. So we have our zones, our tester or test filter going into our feature reader. Now we need to tell the feature reader to make use of those polygons. So in our feature reader, we are going to set our spatial filter. Initiator contains result. Intersects would also work. The difference between intersects and contains is that if it's right on the border, intersects would take it. With contains, it has to be completely within the border. Initiator contains results. And then we hit OK. So now let's run to our feature reader. Now, one of the things that you'll notice here is that what this is doing is it's taking each feature as it comes in. It's initiating that reader, reading that data set, making the query, and then putting out the output features. You'll notice that that takes time. 1, 2, 3, 11, 12, 13, 14. This is not fast. You can imagine that if you had 100 zones, 100 separate polygons, this is going to take quite some time to go through. So that took us just running just to this transformer, took 33 seconds. The thing is, the feature reader can handle aggregates as well. That would give us the exact same area, but with one feature, just one query. So let's improve the performance here a little bit. Let's click on this feature connector here, going into our feature reader, and drop in an aggregator. Not the aggregate filter, we want an aggregator. So we're going to aggregate all those features together. Now let's try running to this. So before it took 33 seconds just to go into the feature reader. Now I aggregate all those features together, it's one feature, and we are done. So that went from 33 seconds down to 3.7 seconds. That's a lot faster. So if you're using those initiators like that, if you have multiple geometries or multiple features, consider aggregating them together. So now we have our postal addresses, and it's just the postal addresses within those aggregates. And if I view with what's in the aggregate here, I'll just hold down the control key and select that's its vector there. So now I can see those are my single family residence zones and the address points within them. So now I need to find which of those points are within 50 meters of my arterial road. So find your arterial road feature type, and let's add a buffer. So we have our arterial roads, let's buffer it out. And we're going to buffer it out 50 meters. We know that this buffer amount is in meters because that's the coordinate system of the data. And we know it's the coordinate system of the data because I told you it was the coordinate system of the data. And now with the buffer, we'll want to filter by the buffer, the features coming out of here. So we'll attach to our buffer a spatial filter. The buffer is in fact our spatial filter. These postal address points, I can just grab this connector here that's going into the string searcher and bring that over to our candidates. Now, generally speaking, I don't like having crossing lines like this. So we have our buffer, which is our filter. These are our candidates. I could rearrange all the transformers so I don't end up with that crossing, or I can just right click here. If I right click on a port in a transformer, I can move it up or down. So I'll move that up. That is now our candidate. Now I want to configure our spatial filter. It's actually the exact same spatial filter as what we have in our feature reader. So if I open this up, this will be multiple filters, pass against one filter. I want to support aggregates, filter intersects candidates, filter intersects, filter contains. Those are in fact very similar. Intersects would work just fine, so we can just leave it as the default. And we'll connect our pass to there. And then we can run into our spatial filter and see what we get. So that gives me 148 addresses. Those 148 addresses are inside of our zones and within 50 meters of a road. Let's continue on. I believe we just have one final section to go through and one exercise. Data joins. Whereas filter transformers divide data into different streams, other transformers bring data streams together, merging the data according to a set of user-defined conditions. Remember that bringing data streams together in Workbench creates a union and does not merge the data by default. Transformers like the feature merger are required for that operation. So if I just had A and B going directly into C, then you just have all of A features and all of B features. If I want some characteristic of B moved onto A features, then I need a transformer to do that. Ultimately, there's two types of merges that you can do. You can merge based on attributes or merge based on geometry. We'll talk about merging based on attributes first, key-based joining. There are several transformers that can join data on the basis of matching an attribute value or a key. Traditionally, the feature merger was the most commonly used for that. But the feature merger has been largely supplanted by a new transformer. Now the feature merger, the way this worked is that we have a requester, something with all of our geometry perhaps, and then a supplier that has the attributes that we want. We join on a supply or requester ID, supplier ID, and then we have our merged features, unmerged requesters, unmerged suppliers, unused suppliers. Now this works, but it's not using any sort of standard nomenclature which is out there, such as SQL nomenclature, SQL terms. The feature joiner is a newer transformer which has largely replaced the feature merger. The feature joiner uses a more standard terminology and is also significantly faster than the feature merger. It uses a different merging technology under the covers. This uses the concept of join modes, inner, left, right. So we have our left feature and our right feature. Then we have our joined, unjoined left, unjoined right. So we can do a left join, an inner join, a full join. If you want to do a right-hand join, you just swap the ports there. So if you're familiar with joins in SQL, the feature joiner makes a bit more sense. Now we also have another transformer called the database joiner. With the feature merger and feature joiner, all the features have to be read into FME using readers or feature reader transformers, or at the very least, all the features have to be in FME. The database joiner is a little bit different. The features that you're merging the attributes from are kept in your database, and then you issue a query to the database for every feature that goes into the database joiner. If you have an enormous database and relatively few querying features, the database joiner can be faster. The database joiner has a much lower memory overhead than the feature joiner and the feature merger. With transformers like the feature joiner, all of your left and all of your right features have to be within the transformer before any joining can happen. If you have a lot of features, it's a lot of memory overhead, we can be caching features to disk, that'll slow down the translation. So in theory, this can be much slower. The database joiner does not have that limitation. Nothing's really being kept in memory. So we're not going to be caching anything to disk. So with large data volumes, this should be faster, but there's a catch. Very much like with what we saw with the feature reader, as each feature goes in, it's initiating that join, and that takes time. So unless you're only dealing with a very small number of requesting features, the database joiner tends to be slower than the feature joiner. If you are really good with SQL, you can also use something called the inline querier. The inline querier basically creates a SQLite database on the fly, populates it with the features that you give it, and then you can give it any arbitrarily complex SQL query to get what you want. I have never used the inline querier myself. My SQL skills are fairly deficient, so this isn't something which I go for, but if you are really good at SQL, give this a shot. Now, there is a performance overhead in generating the initial database, but if you're dealing with large data volumes, it still might be worthwhile. We can also join based on spatial location instead of an attribute. There's a number of transformers that handle this. For one, there's all the various overlayer transformers we have. We have point on area, point on line, line on line, area on area, point on point overlayers. They take the attributes from one and attach it to the other. The neighbor finder will be helpful if the features don't actually overlap. They're just close to each other. We have a base and a candidate, and we look for candidates within a certain distance of the base and merge the attributes based on that distance. The feature reader is much like the database joiner transformer, except the feature reader will return geometry, and it's also not limited to databases. We saw the feature reader right here. We could do a spatial filter. And finally, we have the spatial filter. If you've already read in the data set, then the spatial filter will work. And you can process a number of spatial query types. So we have the pass criteria and this, where are we? There we are, spatial predicates. So there's a number of tests that you can do. So that brings us to the final exercise of the day. We've got a few minutes to go through this. What we're going to want to do is read in some CSV data. There's some CSV data that has some crime data. For our output postal addresses, we want to find out what crimes are happening in that area. So we'll do that as the last thing here. After everything's gone all the way through, we have our attribute manager. We can run up to that point. So we have 148 addresses. We need some crime data for those addresses. Let's add in our CSV reader. We have our CSV reader. The data set. Oops, I went directly to parameters. Our data set is /FME data 2019 /data /emergency. And in the emergency folder, we have our crime CSV file. So go to add a CSV reader, find your dataset, crime.csv. And open. It's very important with CSV files to check the parameters. You cannot change some of these after you've read it in. So here we have our preview. That's not right. So delimiter character, for some reason it didn't actually spot the comma for the comma separated value. That's weird. But it does show that it's really important to come into this beforehand. So we have our ID. Make sure you set your delimiter character to a comma. That's weird that it didn't auto detect that. Okay, so comma, ID is 0, type, month, block. There's no actual geometry here. There's just an indication of block. This information is actually on our addresses. This actually matches up to our address that we've created. So we have our block, but you notice that instead of zeros, it has X's. And for the name of the street, it is all uppercase. So we're going to have to deal with that later on. So we'll hit OK. We don't need a coordinate system because it doesn't have anything. Just hit OK and bring in our CSV file. So there's our CSV file. I forgot to rename it. The feature type names from the file names. That's okay. I'm not going to go back and add this again. If you find that you're looking at something on the canvas and it's not immediately apparent what that is, what I would do is hit Control K for comment. And then you can indicate that this is in fact your crime data. That's a comment. We'll talk more about comments tomorrow in best practices. So I have my CSV, my postal addresses. I've inspected the data already because I previewed it. I need to clean up some stuff. So to merge the data, I need to change the address number. So I am going to rework that, that postal address a little bit. So I still have my postal address. I'm going to put in a string replacer. And in my string replacer, I'll replace, let's do the number. So I'm going to replace number. I'm going to replace it with a regular expression. I'm going to take the first, or actually the last two. So the $sign there, this is a regular expression thing. So it's matching the last two anythings from the end, and I'm going to replace those with X's. So if I run to my string replacer here, what I'll see is when I inspect this, my numbers now, I don't need my geometry, my numbers, there it is. So my number 36XX. I also want to change the street. Before, it's this mixed case. To match what I have on my CSV file, I want it to be all uppercase. So I'll drop in a string case changer. My string case changer, I'll put this after the string replacer. So string replacer, then a string case changer. So in my string case changer, I am going to change my street So in the string case changer, I'm going to change a selected attribute. My selected attribute is street, and I'll make it uppercase. We're going slightly over time here, but we should be done in just a minute. So now I need to build a join key. If I go directly into a feature joiner, I'm just going to drop the feature joiner in right now. So we have our left and our right. In the properties of the feature joiner here, you notice that we can't combine our join keys. We can't make it right here. So that's why I'm going to be using the attribute creator to concatenate them together. I'm using an attribute creator because at this point we have a lot of attributes, and it's just easier to manage if I use an attribute creator. So after our string case changer, we'll bring in an attribute creator, and in our attribute creator, I'll create a new attribute. I will call this join key. So we have our join key attribute that we're going to create. And then here, for our attribute value, we can concatenate together our number, a space, and our street. So that'll create our join key, which we can then use in the feature joiner. If you don't have the feature joiner in there, drop it in. What we just created will be our left, and our CSV will be the right. If you go to join things which are far apart, it's another spot where having that overview window can help. So I need to join what I have from here. We can see that that's here with what's down here. If I click on this, that port, I can then pan around and find what I need to connect it to. Go back to select and click, and it connects it up. So I have what I've created, my new attributes on the left, my CSV for the right. Let's go into our feature joiner. Our join mode is left. Our join on is our join key. Right is our block. And let's see what we get. Actually, let's run from this so we can actually see the number there. So we've got 148 features coming in, 267 going out. That's because there's multiple crimes per block. So for each block, there's actually multiple features coming out of here. We can aggregate at this point if necessary. And we can aggregate based on the object ID. Now we had removed the object ID previously, so we need to go back a little bit here to our attribute manager and bring back our object ID. So if you've done an action in the attribute manager and you want to undo it, there's this action bit over here. In the drop down, I can do nothing. And now that object ID will cascade through all of these transformers to our aggregator. And now we can group by in our aggregator our object ID. Now that means that there's more than one crime occurring at this location. We can make use of that. So let's see, we have a count attribute right here. This will be counting how many features we are actually aggregating together. That count is the number of crimes. Sorry, I should stay there for a second here. So we have our aggregator, crimes, count attribute, number of crimes, and we're aggregating on object ID. So let's run that out. So we have 148 there. Now we have 148 here as well. And if we inspect that, we'll see we have our number of crimes for each address. Basically, it's the number of crimes on that block. That's unfortunate. And we can sort here. So Beach Avenue, questionable place to live. Now you note here that we don't have Beach Avenue, or sorry, we don't have number of crimes defined here. So if I expand this, we have a lot of yellow triangles there. We can quickly add onto our destination feature type, number of crimes, and make that a number. Helps if you spell it right. Oh, I called it number crimes. Sorry, that is actually what it's called. Number. Actually misspelled it two ways. Number crimes. And then we just run to that. And that gives us our final output. Okay, another question had come in earlier. How do we swap around the ports? When I had the spatial filter here, I swapped the ports around. You just right click and you can move your ports. Okay, so that's it for today. Tomorrow's session will be best practices.